Assalamualaikum and salam sejahtera. My name is Nurdini Kristina binti Ahmad Suhaimi. Basically, I'm studying at Polytechnic Sultan Salahuddin Abdul Aziz Shah in Selangor. I would like to present my innovation of IoT system sterilization Arduino UV box. For the first slide is abstract. The design of the sterilization box is based on the ATmega2560 microcontroller, which utilizes the concept of 254 nanometer UVC shortwave radiation and disinfectant spray to increase the effectiveness of the sterilization box. In order to prevent transmission through touch from users through physical contact via sterilization box, researchers designed a system that can make users access sterilization box without the need to make physical contact with the device, namely by using IoT system with the help of applications that can be accessed through the user's smart device. Based on the results of the analysis and experiment that has been carried out, it is concluded that the sterilization box in this study can work optimally at a distance of less than 700 cm. This tool can operate using smartphone media via Bluetooth HC05 module, so it can minimize the process of spreading COVID-19 that occurs through physical contact. After COVID-19 pandemic, as the risk of contracting the virus is increasingly getting higher, and thus it is vital to regularly and routinely disinfect your personal products such as your phone, wallet, keys, and more in a sustainable manner. Since cleaning supply and alcohol pads are in low supply, this project will create a sustainable solution regularly disinfect these small personal products in simple common household items and materials that can be easily found online and most hardware stores. Next slide is the introduction. In the new normal era, people are still facing the shadow of the COVID-19 virus. Plus, the number of people exposed is still increasing to this day. The spread of the virus occurs through direct and indirect contact. Transmission from direct contact can be in the form of touching the patient, or it can be from objects exposed to the COVID-19 virus. From this, an inactivation medium is needed in order to kill viruses or pathogens on objects after use. The COVID-19 inactivation media will use shortwave UVC light with a wavelength of 254 nanometers and a disinfectant spraying device to sterilize those suspected of being exposed to pathogens. The inactivation media comes from the design of the tool whose prototype has been tested for success. The design of the tool is used to sterilize everyday objects that are indicated to be exposed to viruses or bacteria, such as PPE for medical personnel, cloth masks, clothing, shoes, cutlery, food delivery, money, and the like. That way, the possibility of spreading the COVID-19 virus can be minimized and even prevented through sterilizing objects before and after use. In addition, the use of UVC sterilization is not limited to the COVID-19 virus, but can also be applied to sterilize medical surgical instruments, baby equipment, work equipment, and others. This tool is designed using a smart application using the Bluetooth module as a liaison between the smartphone application and the Arduino. Other than that, we have the methodology. So the main fundamental concept behind this proposal is to build UV disinfecting chambers that have already been introduced to the market with all 360-degree full surface disinfectant. This project solves those limits by disinfecting all surface by mechanically turning the items after disinfecting one. After that, the discussion, the use of an Arduino-based systems for sterilization offers a promising solution for a range of applications, um, from medical equipment sterilization to food safety and beyond. The system can be designed to effectively eliminate harmful microorganisms and other contaminants from the environment or object being sterilized, while also being cost-effective and relatively easy to implement. Um, okay, we go to the conclusion. An Arduino based sterilization system offers a flexible and effective solution for a range of applications, but must be carefully designed, implemented, and maintained to ensure its safety and effectiveness. There are several recommendations for this innovation of this project. So first is use of appropriate sensors. Selecting and integrating the appropriate sensors into a UV sterilization box is critical to its safe and effective operation. These sensors work together to automate and monitor the sterilization process, reducing the risk of user error and ensuring consistent sterilization outcomes. For secondly, regular maintenance. Keep the box clean and periodically clean the UVC lamps or bulbs, as dust and dirt can reduce their effectiveness. Thirdly, proper training. Regular training and reinforcement of best practices are crucial to maintaining a safe and effective sterilization process. And lastly, use of data analytics. Data analytics implement data analytics to monitor safety protocols such as ensuring the box is closed during a sterilization cycle, flag any instances of unsafe usage of immediate attention. From this slide, it shows the result from my questionnaire to random people to question about this project effectiveness and did they really need this as their important things to be usually used at home or other places. So first is the answer is most of people on the survey believe that they need to agree for this sterilization box to become an important medium in this era pandemic of COVID-19 to help people stay hygiene. So we can see here it shows 100% people agree with this, and they need sterilization box to be implemented. We have reached the final slide. Okay, this is the picture of my innovation project, the sterilization box. This UV sterilization box typically consists of various components that work together to achieve the function of the sterilization. Here are the primary components and their functions. So basically, I use some of components. So first component is UVC light source. The main component of a UV sterilization box is the UVC light source. We cannot make this project without it. UVC light emits short wavelength ultraviolet radiation that is effective of killing or deactivating microorganisms, including bacteria, viruses, and fungi. Next component is timer and controls. Sterilization boxes typically come with controls that allow users to set the duration of the sterilization cycle. The timer ensures that items are exposed to UVC light for a sufficient amount of time to achieve sterilization while preventing overexposure. So I have an applications in my handphone to set it up, which is Blink. The application's name is Blink, and I can set and adjust whenever I need. Next is I use the transparent container. The box usually has a transparent, allowing users to see the items being sterilized without opening the box. This helps maintain the sterility of the items until they are needed. So we cannot just open and close it. That might be distracted the process. Okay. I also have the adapter that will connect the to main switch or the extension. This adapter is AC to DC, which allow current to flow in one direction. So I use this as my main power supply to turn on or turn off the switch button to light the UV LED. I also use the red USB in the picture that will connect to my PC, and will trigger the Arduino board that have the LED light. Arduino board, which is used to control the lid open or close mechanism of the contactless smart disinfection box. Also, this Arduino board control the miniature micro switch to operate the lid when anything is kept in the device. Okay, and I also use the component of step-down converter, DC to DC power converter that steps down the voltage from its input to its output. In this project, I use HX711 module. HX711 is a 24-bit ADC which amplifies and digitally converts the load cell output. Then this amplified value is fed to the Arduino. Now Arduino calculates the output of HX711 and converts that into the weight values in grams and showed it on LCD. But in this project, I'm not using the LCD. A push button is used for calibrating the system. The DC-DC module is used to reduce the input voltage and output stable 5 volts voltage. So this can stable my voltage. Once the motion sensor, I also use the motion sensor. Motion sensor registers movement, turns off the sterilizing UVC LED and turns on the classic LED light to prevent irradiation of the skin. For the last component is relay. The relay functions as a controller for opening and closing electric currents that can be controlled by Arduino. The basic function of the relay is a switch that is turned on by direct current DC voltage. So to turn on or off AC flow object, a relay is needed that is connected to the Arduino. So these are my components that I use in this project. So that's all for me. Thank you.